Hello again. We had a very nice conversation with Richard last week. Now we will have a more compact and a pure way of receiving his talk again. And thank you very much, Richard, for being with us again. And
You're welcome.
Yes, we can listen to you now. The aesthetics of industrial design is once again with us.
Okay, shall I start my presentation? Off I go. Okay, hello everyone. My name is Richard Herriott, and I'm the an associate professor of industrial design at the Design School in Kolding in Denmark. And Ezra has very kindly invited me to present something of the contents of my book, The Aesthetics of Industrial Design, which came out at the very end of last year, and it's still a little bit fresh. And I will go through the contents of the book. It will be something of a hurried experience, perhaps, because there's a lot of ground to cover. What I'll do is I will draw your attention to the contents of the chapters of the book, of which there are 5, and then you can explore it further on your own time if you feel curious enough. How did the book turn up? Well, the book was originally intended to be an expansion of a 60-slide presentation which I used to give on form giving, which I started teaching more than 10 years ago. And the core of this was to do with curvature and form and line, but specifically lines and surfaces and the geometry of objects that we see in industrial design. And from that, it expanded and became something of another kind of a book, but still with the focus on form giving. But the content expanded to questions about why we see the way we do, the nature of semantics, and I also added in a collection of design problems that often come to vex designers, which aren't written in other places, which is a kind of a compendium. So the book is both a development of my original lecture form and line, and it's also intended to be a collection of all the things that I wish I knew when I was a design student, and which I learned rather more slowly and at greater cost as my career proceeded. Let's move on. The first question is about why we see the way we do. And in front of us here, we've got a nice slice of the Irish landscape, and it represents any slice of the natural environment to which our minds are accustomed to. And the thing with a setting like this is that it all makes sense because it has been developed by the laws of physics, which means that the things that you see there are automatically making the kind of sense that our minds are accustomed to. There's nothing strange, upside down, backwards, or confusing in this environment. This is the environment that our minds evolved to understand and survive and thrive in. And the thing with an industrial design product is that although it is highly artificial, it works best when it doesn't provide weird surprises and confusions. And I'll talk next about how it might be that industrial design objects can be confusing and be strange and baffle us slightly in the way that looking at a nice landscape generally doesn't. This is an example of a very organized bit of an industrial design. And as you can see, the elements there are making sense. We can understand what it is and what it's meant to do. And there seems to be a coherence and an integrity to that shape that we find as satisfying as the landscape that I just showed you. This piece of art has something in common with the natural landscape that our minds are evolved to understand, and that is that it has this powerful sense of clarity to it. It captures our attention. It is an object which makes us not think about what it's for, but rather think about the inherent aesthetic qualities that are present. And that's, again, something that happens when we look at a natural landscape. We don't wonder, what is that for? Our reaction is a very basic, primal, wow, that's lovely, or at least that's okay, I understand it. Art is something to do with taking that kind of aesthetic experience and bringing it in front of the viewer. And good industrial design also tends to have that quality. When we see the object, our first reaction is wow, and then hopefully the object lives up to the promise of wow by functioning in a satisfying and understandable way. The boring old car there is another example of an object that combines multiple functions, and it's a deeply artificial object. And yet, as a result of the designer shaping and forming and organizing all those functions into a coherent whole, the object makes sense. But it need not look like that. He says only through understanding the psychology of humans and our way of reading objects, both learned and intuitive, that we can organize an object that seems to make as automatic sense as this object does. What we're looking at here is a diagram representing the organizational structure of a rhesus monkey. And I show this one because it captures something of the complexity of the visual systems that are inside our own brains. And what you'll notice about this is that it's pretty damn complex and it's interlinked. It's not a hierarchical system. There are areas where parts of the subsystems interconnect up and down the hierarchy. And this gives us a clue to the way in which the human visual system is also organized. Now, I'm not asking you to remember this or to look in detail at any one individual element. The point about this is to understand that what we take for granted, our visual interpretation skills, are not the result of light simply falling into the back of our eyes and landing inside a projector that we then look at and understand. They're the result of complex processes which are very well understood, but still not fully understood, and about which there are plenty of reasons for disagreement or at least discussion. And this complexity of the system is where it is possible for designers to trip up and make shapes that trick our systems into misreading things or not understanding clearly what it is that they are being presented with. And the iterative process of design, of drawing, sketching, and showing things to users is a way for us to gradually find out what it is in the shapes that we are making that are confusing and eliminate them. But it is to do with the system that is complex and has many layers, and this is why it is possible for there to be a wide range of opinions, and it's through the design process and through organizing discussions with users and stakeholders that we can find out what it is in the designed object that is not working. But it is not something that happens automatically. It is the result of hard work and iteration and understanding the complexity of the human visual system. Design is essentially a battle for visual order. I had a little bit of difficulty, in fact quite a lot of difficulty, finding objects that were categorically ugly and confusing. And this is in part because humans do have a fairly strong inbuilt urge to make things that look like they make sense. It's a tendency or a wish to do what David Pye, the English design writer, called useless work. But I did eventually find this picture of a housing complex about a kilometre away from where I live in Aarhus, where the assembly of regular and sensible-looking elements did not ultimately create the kind of visual coherence that we wish to find in a designed object. What we have here is as close to ugliness as I can find. And the ugliness is the inverse of the wow that I talked about earlier. It's basically, and very shortly put, a yuck experience where our response to the object is displeasure, where the visual organization is unsatisfactory and it is not providing something that is reaching the kind of organizational clarity that we find in natural landscapes and in the best industrial designed objects. And on the right of the screen, we've got an incredibly simple and very well organized thing. It is a stainless steel watering can made by Geir Jensen in Denmark. And the thing with this object is that the purpose of the object is to pour water, and the shapes that have been organized to do that task have been refined to a very, very high level, such that what we perceive is not really the function for which this object is designed, but its aesthetic appearance, its skin, the outer surface. Those qualities are reaching us first before we begin to consider what it might be for. And I think what happens with the ugly building on the right is that we are not thinking mostly about what this is for, which is a housing complex for people to live in. What we are struck by is the unpleasant way in which the surfaces are finished and the elements are organized. So the two objects stand in strong contrast to one another. And they represent a lost battle for visual order, and on the right, where the battle for visual order has been won, such that a person will buy this object and spend way over the odds for this object, but hopefully have an object in the form of this watering can, which they find emotionally satisfying and which will fulfill their needs for the rest of their lives. In that sense, the achievement of this battle for visual order has created an object which people will love for its own sake. Why is it then that the business of trying to find visual order is so complicated? What we have on the screen here is a flowchart which shows something of the way in which different theories of visual cognition are related to one another. It starts on the top right of the screen with the physiology of the optical system. And it also connects to evolutionary psychology, which is the theory that the minds that we have are ones evolved for living in a natural environment amongst social human beings, and which we carry with us today to our complex modern world. We also have learned experience, because not only do we have the inbuilt intuitive understanding of the visual environment that we come with, things such as distance, speed, acceleration, whether objects are grouped or not, those kinds of things. But we also learn about the environment for our own experience, but how materials behave when we interact with them, whether things are heavy, whether they deform, whether they bend or break, and whether things look like they're sharp or dangerous or safe and secure. We carry these learned experiences with us as well. And over on the bottom right on the screen, going back to the physiology of the optical system, we've got two competing ideas about how we organize the world, the theories of Gregory and the theories of Gibson. Gibson is essentially a top-down theory, which proposes that there are strong sorting mechanisms that help us understand the world. And Gregory's theory is more bottom-up, such that the vast mass of information that we get is filtered out and processed and interpreted. Now, it's not important for us as designers to know who exactly is right and who is wrong. The jury is, to some extent, still out. Gibson's theory gives us the theory of affordances, and Gregory's theory helps us understand how we sort out visual noise. But by looking into these theories, which is something I strongly recommend, you can find out where it is in our design process and in designed objects that people might be confused or find things hard to understand. So Gregory essentially teaches us about the importance of visual simplicity, and from Gibson we get the idea of affordances and making clear what an object is and how it functions and how we might interact with it. And these have been popularized by Donald Norman in his book, The Psychology of Everyday Things. This flowchart then shows us some of the main arguments for explaining how it is that we see what we see. And the point that I want to get out of this is that there are numerous elements to this, and they are complementary to one another, but not entirely consistent. And this, in a sense, hints to us at the difficulty of the task that we face when we are trying to design an object. It's not something that's automatic. It's not something that we can simply go through as a routine. It's something that involves awareness of cognitive visual understanding in order to understand why objects might be misunderstood. The next point I want to make is a point made by the great English design writer David Pye. And his key point is that every design is a failure. But ultimately, an object has to be either too cheap or too expensive, or it won't do everything that we want it to do, or it does too many things. And our attempts to try and balance these, to compromise these, will lead us to the best design that we might be able to do under the circumstances. But it will always be possible for someone to say that it is too cheap, too expensive, not good enough in some way. And that's because we can't design an object that will do everything and meet every requirement. So the basic understanding here is that with the best will in the world, all a design is going to be, when it works out well, is the best judged compromise based on the knowledge that we have of the environment and the users and the markets into which the object is going to function. And I'd like to draw your attention to the triangular part in the box, where we have 3 points on the apex of the triangle. And our designs can fail functionally, they can fail materially, and they can fail because we've used the wrong production methods. Or put more positively, when we make choices about what the design is supposed to do, the materials it's going to be made of, and how we are going to produce it, then we are able to decide what kind of compromises are the ones that are the most appropriate for the object in question. And so when we start our design, we're going to think, well, what are we going to make this object do? Or what materials have we to hand? Or perhaps what kind of production methods have we available to us, and how can we reuse those? So these are the factors that are influencing how an object is going to appear. And those affect choices about the implementation of our design values, whether we want the objects to be functional or sustainable or economical or usability. And in turn, our attitudes about functionalism, sustainability, economy, and usability affect the choices about the materials and the functionality and the production methods that we're going to deploy. A design process, then, is a balance of these, and this means that design necessitates compromise. And ultimately, as I said, every design is a failure, but hopefully not a very big failure. Now I'd like to turn to the core of the book in talking about the essence of industrial design's form giving. Industrial design has been with us for more than 100 years, and there are forms and norms and ways of solving formal problems of the shape and the appearance of the object that seem to us now to be automatic or normal or natural. And what I'd like to do is I'd like you to consider the origins of the forms that we take for granted as being based in functionalism, as being based in functionality, what the thing is meant to do, so that we don't overlook them or take them for granted. What we have on the screen here is we've got a couple of photographs and drawings of Greek columns. And as you can see, they're highly elaborate and they're made of stone, and they are form-giving, taken to a very, very high degree of refinement. And what I'd like to posit here is that although industrial design has reached for simplicity and refinement and the minimalization of elements for the purposes of mass production and low cost and functionality, they are as refined in their own way as the Grecian columns that I'm showing here on this slide. And when we are designing objects, we are putting into these objects as much refinement as was put into these columns. These columns were originally simply wooden stumps put on the ground in order to hold up a roof to keep people dry. And then they were made of stone. And then at some point, somebody started to do more and more useless work, and then started to consider these objects from an aesthetic point of view. And gradually, it became slightly forgotten what these pillars were actually for. And I think within industrial design, we also sometimes take for granted the qualities of industrial design objects without asking why they tend to look the way they do. And there are reasons for why these objects have these simple forms and these smooth forms and these refined forms. And what I'd like you to do is to consider the underlying drive for these shapes as you are making the shapes that you are drawing. And this leads us to curvature quality, because curvature quality is to industrial design what a very elaborated Grecian column is to classical architecture. Curvature quality matters because of practical reasons, which are the ones that drove an interest in smoothness to begin with. And those practical reasons are that the object should be pleasant to hold, it should be robust and strong, and it should also look as if it is a pleasant object to hold, which leads us to our innate cognitive biases. I talked earlier about the instincts, these are intuitions that we have when we're looking at objects. And we carry these forward to the things that we see around us, such that we want objects that look as if they are pleasant to touch, they look as if they are not harmful. They are both positively safe to look at, and also pleasant to touch. And that leads us to the refinement of curvature quality, which is the ultimate expression of the smoothness and safeness of an object from an appearance point of view. And then as years have gone by, then we have semantics, which is the cultural meaning that is overlaid on top of the practical reasons and the innate cognitive biases that we bring with us. Semantics is where we develop cultural norms based on ultimately physical requirements. And that means that we expect industrial design objects to look a certain way because that's the way they all look. And we have norms about what a high quality object looks like because we have learned from our culture and the way that we behave and our own understanding of objects, what we expect of an object of a certain quality and a certain price. So we have practical reasons and innate cognitive reasons, and then semantics, which are all driving this impetus towards making objects that look as refined in their own way as those Grecian columns that I showed you earlier. And that leads us to the ability to look at the reflections on the painted surface of a vehicle and look at them for their own sake. These reflections on the right of the screen are fluid and smooth, and they have their own aesthetic quality. Where does that come from? Well, we can get lost in the aesthetic attractiveness of these beautiful flowing forms on this glossy surface and forget that the reason that they are there is because the underlying forms that they are reflected of have to meet the requirements of being robust, durable, but also visually safe to look at, and also to fulfill the semantic demands that we expect of an object like this. And when we have those three things in place, then we have the result of that is a highly refined and very, very literally and metaphorically polished three-dimensional form that you see on this car here. And at that point, we are able to look at those reflections and go, wow, and forget all the things that led to those reflections being there in the first place. And on the right-hand side of the screen, we see a mixer by Brown from the 1950s, where again, this visual refinement has reached a very high level of perfection. And we have a huge amount of careful polishing and shaping of an object that, remember, doesn't need to really look like that in terms of pure engineering requirements. It is the cognitive psychological needs of humans that drives the designer to make an object that looks like this. And the end result is that we have an object which has this wow factor and where we can develop an emotional relationship with the object which surpasses its plain, boring engineering requirement. Industrial designed objects are made of a variety of forms which are compounded together. And this interest in smoothness and in refinement is what leads us to try and turn those forms into unified wholes. And on the right-hand side of the screen, you can see this chamfered corner on the back of the Ford Granada. And this is an example of how a designer will use the possibilities available to him or her to create shapes that not only have these functional requirements met, but also satisfy our aesthetic inclinations. And this object, like the car I showed you earlier, is a collection of different functions which have been unified such that what we perceive is not the fact that it is a vehicle for moving people around the place, but an object that has aesthetic qualities of its own right. And what happens when we can avoid the pitfalls of our complex visual cognitive systems and we can balance those compromises in a satisfactory way, we can present an object which the user will look at and perceive for its own sake rather than the functional purpose for which the object was made. This then leads me to section 4 of the book, where I have called it rather humorously Overcoming the Engineers. And I would like to stress that my attitude towards engineers is slightly caricature, that I know that most of them are hardworking and careful people who understand the needs of designers to make objects that are aesthetically satisfying. But occasionally they do tend to put functional requirements first, and This provides work for us because it provides challenges that the engineers might present to us. And what I've done in this chapter is I've gathered some of the common problems that tend to come from the engineering side and about which designers need to be aware in order that they can present to the consumer and the user an object which not only meets engineering requirements, but also fulfills the aesthetic appeal that an object has to have. And they come under basically 5 categories. Topology, which is the relation of open and closed lines to the positive and negative volumes on the object. So this is the geometry, the mathematics of the form, squares, cylinders, and pyramids, and spheres, and conical forms, and how these objects are interacted with or interrelate to the gaps, the panel gaps, and joint lines and graphics that might be put on the object. The rules of topology, how positive and negative forms meet one another, will affect the sequence of assembly, and that comes to us from the engineering side. Sequence of assembly, in turn, governs the edges and joints and the panel gaps, which I talked about, and the interrelationship of the edges and joints and panel gaps on complicated three-dimensional shapes can be affected by the Gestalt theory, how we perceive the figure and the whole and the object and the background. And it also relates back to semantics, the understanding that we gain of how high quality objects are made and how things are put together, generally speaking. And those factors then lead us to need to address issues of parallelism, alignment, consistency, and context. What are those? Parallelism is the phenomenon of where we wish to have lines on an object either clearly parallel or clearly divergent. And the underlying this is the idea that the forms should look deliberate, as if they are meant to be like that. There is not an instruction manual or an explanation that comes with an object. We have to present an object to the user that looks like it can be understood relatively easily. And where we've got lines on an object that are vaguely parallel or not clearly going one way or another, that can lead the user to be confused or at least puzzled about the motivation of the designer and why the object looks the way it does. So the idea here is that we should make the object look deliberate. What is there should look like it is there for a reason, or else not draw our attention to it at all. Consistency is about making sure that the object looks the same over all its parts, that it adheres to the idea of visual coherence and visual homogeneity. The object should look as if it is of a piece, and that the form language that you use, which consists of a set of rules, have been applied uniformly across the object. And lastly, context. This is an issue of the fact that a detail of an object might look okay when seen up close, but does it make sense when seen as a whole? Designers have a touch of us obsessive compulsive about what we do, and we spend a lot of time looking at the details of things, and we sometimes can forget to zoom out and look at the details in context. So what I get from this here is that we need to sometimes step back from our creative and analytical work, our up-close creative and analytical work, and step back and look at the object as a whole and ask, do all the individual elements make up a consistent gestalt? What might look good up close might not make sense when seen from a distance. We need then to step back and get distance to our work so that we can analyze it and ask whether or not that looks the way that we would have drawn it had we had the chance. I have here a very one of my favorite examples of where the engineers won. What we have here is a B pillar, or a pillar on the window of a railway carriage in Denmark, and the vertical element is meeting the horizontal element with an uneven gap. And that is the kind of thing that looks as if insufficient thought was applied to the aesthetics. That works, but that is not visually appealing because that does not look the way that we would have drawn it. What we read from that, from our understanding of how objects are made, is that this was a low-cost option. However, by the time that you have got to the stage of having one of these pillars in front of your face as an engineer, it is probably too late to go back and re-engineer the interior of the train to avoid that gap. This unfortunate joint was the result of the need to assemble the interior components a certain way. And I would reckon that because the designers didn't do experimental cross sections of each of these joints, they probably didn't realize until too late that they had this feature right in front of the face of the passenger, giving them the signal that the train was shoddily and poorly assembled. From this, we get the idea that people can read whether or not an object has been assembled with apparent expense or not. This joint looks cheap. Visually, semantically, this is unsatisfying. And this, lastly, brings us to this concept of semantics, where we're talking about how the functional and the cognitive experience and intuition that we have is overlain by social and cultural factors. So, for example, the colors blue and yellow on their own mean nothing, but we learn through experience that they are variously the colors of Sweden or the colors of Ukraine. So that when something is painted yellow and blue, and when we are in a giant department store, we are very much reminded that these furniture items are the product of Sweden, and from that we can infer that they might perhaps be high quality items or known for their design. So the semantic meaning of yellow and blue is not an automatic thing given to us by our eyes or by our inbuilt cognitive systems, but it's something that we learn through our interaction with the human world. So semantics is essentially the way in which our experience from the human world is overlaid onto objects and transferred to these objects. So in the final chapter, I discussed this, which tells you what product semantics for, and I also addressed the limitations of product semantics. Product semantics are structured by things like the semantic triangle, which I'll come to next. And the semantic approach also explains how we see. And from this, we understand that the product is a channel of communication. The Norwegian writer Rune Mona has a book called Design for Product Understanding, which I draw from here. And the key message here is that the product is trying to communicate something. Its function, but also its socio-cultural meaning is also communicated to the user. And when an object is presenting us with confusing and strange shapes, things that don't make sense, that is what I would consider a kind of noise that gets in the way or confounds the goal of the product as a channel of communication. So I did talk about the way in which an object can look as understandable as a natural landscape. But I would also like to ask you to consider the idea of the object as communicating a message, an abstract message, rather than it merely being the result of the laws of physics being applied in a logical way. And that message might be, this object is for people who are very outgoing, this project is high class, this project is for a man, this project is for a woman, this is project for somebody who doesn't want to be seen as either a man or a woman. These are the ways in which products communicate things. And when I choose to put on my clothes in the morning, or when I choose to buy things, I'm not only asking, is this going to keep me warm, but I'm also asking, does this product represent me? Does it represent me to the world? And does it represent me to myself? So those are some of the issues that arise from product. And here we can see here two different radios. They both do the same thing, but they have very clearly different meanings in terms of form giving. One is very geometrical, and I think some people would probably view it as being cheap. And on the other side, we've got an object made of leather with the ivory colors that draws on our cultural understandings of retro objects, and also our understanding that leather is expensive, to tell us that this is a high quality object. And on the right side of the screen, we have the semantic triangle, where we have the sign, the referent, and the thought. And in this instance here, the radios are signs. They are signs of something. They are a message, and they refer to something. They refer to listening to radios. They also refer to the cultural meanings that we can draw from these materials. And that then leads to the thought, which means I can listen to the radio, or I want a radio that represents me and represents the lifestyle that I have. On the right, we've got a kettle, a cheap kettle, a no-name kettle, and on the left we've got a kettle designed by a Japanese design consultancy, and both of them functionally fulfill the requirements to heat water relatively quickly. But one of them is using the form language of technicalism, of simplicity, of incredible refinement, and also the concepts of affordances in terms of the handle and the spout and the division of the elements to create an object of surpassing calm and order. And I would suggest intuitively we understand that this is not a cheap kettle. And on the right, we can see a kettle where there has been an attempt to organize it, but it is lacking the refinement and it's lacking the visual coherence to make an object that looks as if we're going to pay 5 times over the odds for it.
Or, for example, an Alessi kettle.
What?
Alessi kettle, like Whistling Bird by Michael Graves.
Oh, yes, yeah, there's another one. Yeah, there's a kettle which also plays with semantics and also has humor. And there's another kettle which is also carrying an aesthetic message, which is attracting us to the kettle. And we'll end up loving that kettle just because of the way it is. And I think the same thing goes for the kettle on the left.
Yeah.
But the kettle on the right is one that I found left out on the road to be thrown away. And what I'm trying to get at here is that the semantics of these two kettles are profoundly different. And I think one of them, the kettle on the right, and I think it's an American kettle, I think its only message is that this is a curvy object. And on the right, on the left side, the Japanese kettle is carrying an awful lot of deeper semantic resonances, which is expressing to us that this is as beautiful as a kettle can possibly be. But that is where semantics comes in, and both these objects can be decoded. Now, I can't categorically tell you exactly why most people will find the kettle on the left more attractive than one on the right, but I believe it has a lot to do with the semantics of the kettle, plus also the way the detailing has been handled. The kettle on the right it looks expedient, and it seems to convey cheapness. Okay, so this then leads us to how can we deploy semantics, and we can use this by research into the market, finding out about the psychology of the user, research into the knowledge of culture, understanding of material, color, and finish, and product requirements. That data is gathered by you, the designer, and then you organize that in a semantic way such that the message is coming across loud and clear. And then you also remember to check with the user that the things that you're designing are making sense to them in the way in which you think they are. So the users must come into this process, specifically when you're dealing with semantics, in order to check that your coding is corresponding to their coding. And now we've reached the end, and at the conclusion, I would like to say that what I've argued for is that design is the specification of visually coherent objects, visually coherent like nature, that satisfy human emotional and rational needs, that speaks to the person as a human being, but also satisfies their need for functional utility. It's both of those things are essential in a designed object. Engineers tend to focus on the rational and artists tend to focus on the emotional. Designers are balancing the two, providing both emotional and rational satisfaction. And in another way of saying, design operates at the intersection of the qualitative, the quantitative, and the intersubjective. So qualitative is about things that we feel, our emotional side. Quantitative is what we can measure. And also the intersubjective is what it is that we can agree between us these things represent. It is subjective, but there's also a strong degree of intersubjectivity, and we must be aware of that. And this is where user involvement comes into the process. That although I've not talked much about it, it is through user inquiry that we can determine whether our aesthetic ideas are in fact resonating with the user in the way that we wish. And design is in constant flux because the subject of research changes, the means of research changes, and the user changes. Yeah. So how it is that we find out is constantly evolving. The methods that we use and the context of our research is changing. Society is in flux. And finally, our users themselves change both in time and in the course of their lives and in relation to other people. So it ain't easy. And this is why it is not the easiest thing in the world to make objects that look as satisfying as a work of art or as visually understandable as the natural world into which or for which our mind was evolved. And that then concludes my presentation, and I would like to thank you very much indeed.
Thank you very much, Richard. It was a pleasure to host you again. It was a really pleasure to host Richard Herriott, who is an associate professor at Design School of Denmark and has an extensive focus about design aesthetics for quite a while. And now he has matured his works in his book, The Aesthetics of Industrial Design, Seeing, Designing and Making. And I really congratulate you about publishing this book. It is
Thank you.
It does deserve an extensive reading also. It is a good opportunity for us to cover this the content of this book by your talk. And yes, we will look deeper to your book. Many thanks again, and it was really enjoyable to host you. Hope to host you in person also in Izmir or in Istanbul. Thank you very
That
much.
would be great. Yes. Thank you very much. It was very nice. I want to say how thankful I am and grateful I am for the opportunity to talk about my book and its contents. And I only wish that I had more time to go into the material. I've really only acted as a signpost. So I hope that your curiosity has been piqued and that you can look further into the contents of the book. Thank you very much indeed.
Thank you very much, Richard. I congratulate you and wish you success for your ongoing researches too. Thank you very much.
Likewise.
See you. Bye bye.
Bye bye.